Dear students, in the last tutorial we studied the basic concepts of differentiability. Now we shall discuss some critical problems mathematically and graphically. First question is, discuss the differentiability of f of x equal to modulus of x minus 1 plus modulus of x minus 2. Critically we have to discuss these one, then we shall discuss it graphically. First of all, you see that if we divide the domain, say this is negative infinity to positive infinity, negative infinity to positive infinity, okay, so that there are two critical points 1 and 2, so put it here, say this is 1 and another point is 2, so that the domain, total domain is divided into three parts, three segments, minus infinity to 1, next is 1 to 2, and another part is 2 to positive infinity. Okay, so if you take a point in between minus infinity to 1, say the best example is 0, say x is equal to 0, and put it here, so you will get 0 minus 1 is equal to negative. Okay, 0 minus 1 is equal to minus 1, so the part is negative, makes negative, so you take minus of x minus 1, okay, minus of x minus 1, other part you say if you put it here 0, then it will be minus 2, so the sense is negative, so minus of x minus 2. In this way you have to divide the domains and the respective functions. That means for this is only for x is less than 1, okay, for x is less than 1. Another part you take a value, say in between 1 and 2, suppose the best example is 1.2, isn't it? 1.2, okay, 1.5 is the middle of these 2 points 1 and 2, so put it here, 1.5 minus 1, that is equal to 0.5, so this is a positive value, so we have to take positive x minus 1. Next is 1.5 minus 2, that is negative, so it will be minus of x minus 2, and this is for 1 less than or equal to x less than 2. That means we have taken the value in between 1 and 2. Next, other part is 2 to positive infinity, so you may take any value, say 3. Okay, you put it here, 3 minus 1 is equal to 2, that is a positive number, so you have to take positive x minus 1, and again put it here, 3 minus 2, so this is again a positive number, so you put positive x minus 2, and the domain is x is greater than or equal to 2. Okay, so the respective functions are created, minus x minus that is minus twice x, and this is plus 1 plus 2, that is equal to plus 3, and this is for x is less than 1. Okay, another part is here x is cancelled, so minus 1 plus 2, that is equal to 1 for x 1 less than or equal to x less than 2, and the third part is x plus x is equal to twice x, and twice x, and minus 1 minus 2, that is equal to minus 3, for this is for x is greater than or equal to 2. So all the domains and the respective functions are created, minus 2x plus 3, next is 1, next is 2x minus 3. So if I draw this one, first of all, better I want to do it mechanically, that means mathematically. After that I shall draw the graph of this function so that you can understand it better. Okay, first of all, LHD. What is LHD? LHD means left hand derivative. We have discussed everything, and one thing I want to discuss here, when x is less than 1, in the domain, first domain, x is less than 1, we have f of x is equal to minus 2x plus 3, isn't it? Which being a polynomial function is continuous and differentiable, obviously. When you take 1 less than or equal to x less than 2, we have the function f of x is equal to 1, which is a constant function, is differentiable in between 1 and 2, obviously. And take x is greater than or equal to 2, and you are getting the polynomial function 2x minus 3. This is also a continuous and differentiable function. Thus the possible points of non-differentiability is only at x is equal to 1, this point x is equal to 1, or the point is x is equal to 2. So we shall first of all discuss at the point x is equal to 1, next x is equal to 2. So LHD, left hand derivative at x is equal to 1. So I write it here, L of f dash 1, L of f dash 1, left hand derivative of f of x at the point x is equal to 1. So we know the definition, we last day discussed everything. Limit h tends to 0, okay, f of, we are just writing the definition, f of 1 minus h minus f of 1 upon h. This is negative h according to the definition. Obviously you can say the 1 minus h minus of 1, so 1 is cancelled, minus h, and limit h tends to 0, h tends to 0. Now what is the value of f of 1 minus h? You just see that this x is less than 1 minus h is a negligible positive quantity, so that means 1 minus h is means x is less than 1. So find the domain, x is less than 1. When x is less than 1, your function is minus 2x plus 3, isn't it? Minus 2x plus 3, carefully watch, minus 2x plus 3, and this x will be replaced by 1 minus h, okay? So minus 2 times x is equal to 1 minus h plus 3, okay, plus 3, and minus of f1, minus f1. What is f of 1? F of 1, that means function of, value of the function f of x at the point x is equal to 1. At the point x is equal to 1, the value is 1, okay? So put 1. If you don't understand anything, then obviously you should write in the comment section, and whole divided by minus h, that is equal to limit h tends to 0, limit h tends to 0, denominator is minus h, denominator is minus h, so multiply minus 2 plus twice h, and this is plus 2 is cancelled, and you are getting it as limit 2h divided by minus h is cancelled, so you are getting only minus 2. Okay, this is the result is minus 2. Limit h tends to 0 of twice h divided by minus h is equal to minus 2. Obviously you have to write, since h is tending to 0, so therefore h is not is equal to 0. When h is not is equal to 0, then obviously you can say that the fraction in the h's will be cancelled, and limit h tends to 0 of minus 2 is equal to minus 2. This is your LHD. Now find the RHD, right hand derivative at the point x is equal to 1, that means r f dash 1, that is equal to, according to definition, you know everything we have discussed in earlier tutorial. You may see this tutorial, the link will be given. Limit h tends to 0, f of 1 plus h minus f of 1 whole divided by h, okay? So this is equal to limit h tends to 0, h tends to 0. What is f of 1 plus h? Okay, here you see that 1 plus h, that means x is more than 1, x is more than 1. Find the domain, x is more than 1, x is more than, yes, this part, x is more than 1, 1 is less than x means x is more than 1. When x is more than 1, the value of the function is 1, so write 1, okay, 1 minus f of 1. What is f of 1? That means the value of the function f of x at the point x is equal to 1. Obviously at x is equal to 1, the value of the function is 1. So put 1 and whole divided by h. So obviously this value is equal to 0. Now say that the RHD is equal to 0. The RHD is equal to 0 and LHD is equal to minus 2. Since LHD is not is equal to RHD at the point x is equal to 1, therefore the function f of x is not differentiable at the point x is equal to 1. The first point is discarded, that means the function is not differentiable at the point x is equal to 1. Now we take the second point. What is the second point? The second point is x is equal to 2. We shall now discuss. You have to see every step. After completion of this, I shall show the graph, how to draw this graph, and how to judge the graph so that we can find the differentiability at the given points 1 and 2. Okay, now again you have to find out LHD. LHD for which sense? That means this is L of f dash 2. Okay, that means you have to find out the left hand derivative of the function f of x at the point x is equal to 2. Use again the same definition, limit h tends to 0, f of 2 minus h minus f of 2 whole divided by minus h. Okay, so limit h tends to 0, f of 2 minus h, that means x is less than 2. 2 minus h, h is a negligible positive quantity, so 2 minus h means x is less than 2. X is less than 2, find it. X is less than 2, yes, this is the domain. X is less than 2, then the function is 1, so put it here 1. Okay, 1 minus f of 2, that means the value of the function f of x at the point x is equal to 2. What is the value of the function x at x is equal to 2? This is x is equal to 2, that means the function is twice x minus 3, means 2 into 2 minus 3. 4 minus 3 is equal to 1, so put it here 1 whole divided by minus h. What is the value? Value is equal to 0, isn't it? The value is equal to 0. So your LHD at the point x is equal to 2 is 0. Now find RHD. RHD. Carefully watch, this is very important. If you commit any mistake, then everything will be absurd, and that means the right hand derivative of the function f of x at the point 2. So this is r of f dash 2 is equal to, write the definition, limit h tends to 0, f of 2 plus h, okay, f of 2 plus h minus f of 2 whole upon h. Okay, now this is equal to limit h tends to 0, h tends to 0, f of 2 plus h. What is 2 plus h? Means your x is more than 2. X is more than 2. This is the domain, x is more than 2. That means you have to put twice x minus 3. And twice x minus this x is replaced by 2 plus h. So, right, 2 times of x. That means 2 plus h. 2 plus h minus 3 minus f of 2. Similarly, f of 2 is equal to 1. I have discussed 1 whole divided by h. What is the result? This is a limit h tends to 0, h tends to 0 whole divided by h, and this is 2 to the 4, okay, right, 4 plus twice h, and this is minus 4, this 4 will be cancelled, and this is twice by h, twice divided by h, and h will be cancelled, so the limit will be 2. So RHD here 2. What is the LHD? LHD is equal to 0 and RHD is equal to 2. Again you are looking that LHD is not is equal to RHD at the point x is equal to 2. Therefore f of x is not differentiable, at the point, there is no at the point x is equal to 2. Okay, so now I want to draw the graph. If I draw the graph, you can understand it better. The first function is this one, minus twice x plus 3. Slope is minus 2. This is like mx plus c. M is equal to minus 2. That means the line, this is a polynomial, linear polynomial, means it will make a straight line. You know, in 9th standard it was discussed. So these are the axes. Okay, this is the domain line, and the first line is minus 2x plus 3. Minus 2x plus 3 will pass through this point. Okay, before that you have to draw the critical points 1 and 2 on the domain. Say this is 1 and this point is say 2. Okay, and the line minus 2x plus 3 will make obtuse angle with the positive direction of x-axis, but it cannot exceed 1, because what is given x is less than 1. So for this your line will come up to 1, not more than that, like this. Okay, not more than that. Next is the function f of x is equal to 1. 1 is a constant and it is obviously parallel to x-axis. You know this one, in 10th standard you got this one, but your domain is from 1 to 2. For this it will be parallel from 1 to 2. So there is a corner created, and at 2, for x greater than 2, your function is twice x minus 3. This is again type of mx plus c. M is equal to 2. This is a positive number, so the line will make an acute angle with the positive direction of x-axis, and it is going to this way. Okay, and you see that x is more than 2. For this the function is twice x minus 3. This is drawn. The total graph is drawn. This is your y is equal to f of x. The total graph is drawn. Now last day we discussed, if you find in a graph if there is some corner, that at the corners the function will not be differentiable. Other part maybe, in the other parts maybe the function is differentiable, but any corner the function is not differentiable. Okay, so you find that the point, there are two corners in the graph at the point x is equal to 1, other point is at x is equal to 2. So this point at x is equal to 1, you will find that the function is not differentiable because there creates a corner. Also at the point x is equal to 2, the graph creates a corner at this point. So for this, the function is discontinuous at both the points 1 and 2. So we have also discussed at the point x is equal to 1 and at the point x is equal to 2, the function is not differentiable. Okay, so we have just drawn the graph and we can conclude that the function is not differentiable at the points 1 and 2. So when you use this property in joint renders, then just drawing the graph you can conclude that the function is not differentiable. But at the CBSE board exams, you have to write all the mechanical or mathematical process. Okay, next. The next question is, if f of x is equal to x square plus 3x minus a, this is a polynomial, and bx plus 2, the domains are given. First domain is x is less than or equal to 1, second domain is x is greater than 1, is everywhere differentiable. This is given, and is everywhere differentiable, that means differentiable function. Find the values of a and b. Now for x is less than or equal to 1, it is given the function is a polynomial function. For x is greater than 1, the function is again a polynomial function. Since the polynomial function is everywhere differentiable, the f of x, the function f of x is differentiable for all x greater than 1 and also for all x is less than 1. Okay, we have to use the differentiability of f of x at only x is equal to 1. This is given, x is equal to 1, to find the values of a and b. Now last day we have discussed a theorem. What was the theorem? F of x is differentiable at a given point. Differentiable here, the point is x is equal to 1. So obviously it implies that the function f of x is, what can I write, is continuous at the point x is equal to 1. Okay, last day we discussed on it, and obviously you should see this one, otherwise this will not be clear. X tends to, I have given a link in the description, you see this one. Limit x tends to 1 minus of the function f of x is equal to limit x tends to 1 positive of f of x is equal to f of 1. Okay, so what is limit x tends to 1 minus of fx? Obviously you will find it as a limit x tends to 1 minus of the function x is less than 1. X is less than 1, that means this function x square, write it, x square plus 3x plus a, and this is equal to limit x tends to 1 positive of the function y x is more than 1. X is more than 1, then the function is bx plus 2. Bx plus 2, write it here, bx plus 2, that is equal to f of 1. That means the value of the function f of x at the point x is equal to 1. X is equal to 1, the value of the function at x is equal to 1. So 1 square plus 3 into 1 plus a, that is 4 plus a. So write 4 plus a. Okay, 4 plus a. Now what will be the values? 1 square plus 3 into 1, 4 plus a, that is again 4 plus a. This one will be b into 1 plus 2, that is b plus 2. B plus 2, that is given 4 plus a. Okay, 4 plus a. So from the first two you get, write it here, a minus b plus 2 is equal to 0. Number 1. The function f of x is differentiable at x is equal to 1. That means LHD at x is equal to 1 is equal to RHD at x is equal to 1, isn't it? So according to definition, limit h tends to 0, f of 1 minus h minus f of 1 whole divided by h minus h is equal to limit h tends to 0 f of 1 plus h minus f of 1 whole divided by h. Okay, so write limit h tends to 0 f of 1 minus h, that means x is less than 1. X is less than 1, that is x square plus 3x plus a. So replace this x by 1 minus h. So this is, carefully write, 1 minus h whole square plus 3x, that is plus 3 into 1 minus h plus a minus f of 1, that means value of function f of x at the point x is equal to 1. At x is equal to, it will be 1 square plus 3 into 1 plus a, that is 4 plus a. So write 4 plus a, because there is a minus sign, so minus 4 minus a whole divided by minus h. And right side, this is limit h tends to 0. Write carefully, otherwise everything will be absurd. F of 1 plus h, that is x is more than 1. X is more than 1, then the function is bx plus 2. So bx, x is equal to 1 plus h, bx plus 2 minus f of 1, just discuss, minus 4 minus a, minus 4 minus a. Okay, now these two a's are cancelled, so cancel these a and carefully write limit h tends to 0, h tends to 0 whole divided by minus h, and break this 1 minus 2h plus h square plus 3 minus 3h, and this is minus 4, and right side limit h tends to 0, denominator is h, and this is b plus bh, and 2 minus 4 is equal to minus 2 minus a. Okay, so left side you see that 3 plus 1 is equal to 4, 4 minus 4 is equal to 0. So only the h's will be written, h square minus 2h minus 3h minus 5h whole divided by minus h. What is the limit? Limit h tends to 0. Limit h tends to 0. Right side, limit h tends to 0. Now on right side you have to apply equation number 1 that you got earlier. What is this? A minus b plus 2 is equal to 0. Here this is, if you take minus common, then it will be a plus 2 minus b, so that is equal to 0. Only you have b h, other part is 0. So this is, if you take h common you can cancel. Okay, limit h tends to 0, and in bracket it will be minus h plus 5, because h is not is equal to 0. Since h tends to 0, right side is a limit h tends to 0. Similarly you can cancel h and you will get only b. So b is a constant, so limit of b is again b. So you are getting 0 plus 5 is equal to b, that means b is equal to 5. So b is equal to 5. Now you just put this v, the value of b, in 1. So here I write, from 1 we get a minus b, b is equal to 5 plus 2 is equal to 0. Therefore a is equal to 3. So the values are a is equal to 3 and b is equal to 5, hence the result. Next, this is a logarithmic function. Discuss the differentiability of the function f of x is equal to modulus of log of x base e. Okay, so we shall use the definition of logarithm. Actually, break this one, log of x, that is if you take minus log of x base e, and obviously you know this will be in 0 less than x less than 1. How do I write this one? Now I show this one again. You write log of x base e when x is greater than or equal to 1. Now see, how do I write this? And actually we know the graph of the logarithmic function. You draw this one. What is log of x base e? This is the graph of the function. This is the log of x base e, and it passes through the point 1 comma 0. In 11th standard we discussed on it, 1 comma 0. Now see that some part of the curve is below x-axis, that means negative, and some part is above x-axis. What this part is your positive part. Okay, so from the domain, that means from 1 to positive infinity. From 1 to positive infinity means when x is more than 1, the value of the function is positive. For this we have written positive log of x base e. Other part you see that from 0 to 1, in between 0 to 1, the part is on negative side, that means on the below the x-axis. For this part is negative, so we have written minus log of x base e when 0 less than x less than 1. Okay, these two parts, the domain parts, are written and the corresponding functions are also written. Now clearly f of x is differentiable for all x greater than 1 as well as for all x less than 1, isn't it? There is no gap. So we have to check the differentiability at the point x is equal to 1, for which, for the modulus of log of x. Now what happens when you get logarithm as modulus in between modulus? Then obviously the negative part, this negative part will be gone on upper side of the x-axis in this way. So this is the curve for log of x base e, but when you draw the graph for the modulus of log of x base e, then the positive part will be as usual, this part, and this negative part, that means below the x-axis, it will be on the x-axis and will be the mirror image with respect to x-axis, like this. Okay, so 1, 0, and it will be nearer to y-axis, like this, near about like this. So this curve is for modulus of log of x base e. Okay, this is very important. Now you observe carefully, there is a corner for this. The function is not differentiable at the point x is equal to 1. This is clear. But since you have to write in your board exam or in your school exam, so you have to show that mathematically that the function is not differentiable at the point x is equal to 1. It is continuous at the point x is equal to 1 because there is no gap, but it is not differentiable because there creates a corner in the graph. So we have to take the LHD at the point x is equal to 1. Okay, LHD at x is equal to 1. So that is equal to LF dash of 1, that is equal to limit, write the definition, limit h tends to 0, the point is 1, so f of 1 minus h minus f of 1 whole divided by minus h, isn't it? Limit h tends to 0, limit h tends to 0, f of 1 minus h, that means x is less than 1, so x is less than 1 means minus of log of x, so write minus log of x is 1 minus h base is e, and minus f of 1. What is f of 1? That means value of function at the point x is equal to 1. X is equal to 1, the log of 1, that is equal to 0, so write 0 whole divided by minus h. So this is equal to minus limit h tends to 0, log of 1 minus h whole divided by minus h. So this is equal to minus, and this part is 1. So your LHD is equal to minus 1. Now you find the RHD. Okay, the RHD means LF dash 1, that means left hand derivative of the function f of x at the point x is equal to 1. Use limit h tends to 0, f of 1 plus h, okay, 1 plus h minus f of 1 whole divided by h. So limit h tends to 0, these are all critical discussion. Limit h tends to 0, x is more than 1, so x is more than 1, this part x is more than 1, so plus log of x, so log of 1 plus h, x is replaced by 1 plus h minus f of 1, obviously you at x is equal to 1, log of 1 means 0, so this is 0 whole divided by h, so the limit is 1. So see that RHD is equal to 1 and LHD is equal to minus 1. Since LHD is not is equal to RHD at x is equal to 1, therefore function f of x is not differentiable at the point x is equal to 1. Okay, this is the proof. But in the graph you earlier got that at the point x is equal to 1, there creates a corner. For this the function was not differentiable at the point x is equal to 1. Next, This is our last discussion. So that f of x is equal to modulus of x minus 2 is continuous. This is continuous but not differentiable at the point x is equal to 2. First of all, I want to draw this one, and then mathematically we shall show. If you want to draw the curve for x minus 2 means mx plus c, y is equal to mx plus c, mx plus c, m is equal to 1x minus 2, mx plus c. So what will be the curve? This is actually a straight line because it is a linear polynomial x minus 2. We do not discuss about the modulus. Okay, first of all, you just draw the function x minus 2, and your function will be like this, x minus 2. This is y is equal to x minus 2, x minus 2. But if you take the modulus of this function, then the negative part will be above the x-axis, So when you draw the modulus of x minus 2, then the positive part will be as usual and the negative part will be mirror image with respect to the x-axis. That means the negative part will be above the x-axis. So this is your graph actually for f of x. This is the given function f of x is equal to modulus of x minus 2, and obviously you see that you can draw this graph without lifting your pen, so the function is continuous at everywhere on R. But since there creates a corner at this point 2, 0, so the function is obviously not differentiable at this corner, at this point x is equal to 2. After just observation of this graph you can conclude this one, but mathematically you have to show. Okay, so first of all, f of x is equal to, write the break this one. Okay, first of all you break this one, positive x minus 2 when x minus 2 is greater than or equal to 0, and negative x minus 2 when x minus 2 is less than 0. And what is it? This is x is greater than or equal to 2, and from here you are getting x is less than 2. So these are the domain actually. X is more than or equal to 2 and x is less than 2. The functions are respectively plus x minus 2 and minus of x minus 2. Now you find the LHD. LHD means left hand derivative of the function at the point 2, because you have to check at the point x is equal to 2, at the point x is equal to 2 there creates a corner. Okay, so this is a limit h tends to 0, very simple. If you can understand the graph, then it will be very easy to you. Otherwise mathematically you have to learn. F of 2 minus h minus f of 2 whole divided by h, negative h. So this is equal to limit h tends to 0 and f of 2 minus h, x is less than 2. X is less than 2, function is minus x minus 2, minus of x minus 2, that is minus x plus 2. So minus x 2 minus h plus 2 minus of f of 2. At x is equal to 2, the value of the function will be 2 minus 2 is equal to 0. So this part is 0 whole divided by minus h. Okay, so write it, limit h tends to 0. This is minus 2 plus h plus 2 whole divided by minus h. These two are cancelled and h will also be cancelled, and you will get the result as minus 1. So LHD is equal to minus 1. On the right hand derivative at x is equal to 2, that means r f dash 2 is equal to limit h tends to 0, f of 2 plus h. If you can write the definition properly, then there will be no problem to find the limit correctly. Limit h tends to 0, f of 2 plus h, x is more than 2, then it is x minus 2. So write 2 minus h minus 2, and this is minus 2, and f of 2 earlier got, this is 0, so write 0 whole divided by h, 2 is cancelled, and getting this is 2 plus h, x 2 plus h, this one is 2 plus h, because the value of x is equal to 2 plus h. So h by h is equal to 1, so the limit is 1. So you see that LHD is equal to minus 1 and RHD is equal to plus 1. Since LHD is not is equal to RHD at x is equal to 2, so the function f of x is not differentiable at the point x is equal to 2. Okay, so this is the proof for differentiability. Okay, another thing is you have to show the function. And what about the continuity of the function? Obviously you see that you cannot you do not lift your pen to draw this graph. For this, the function is continuous at this point. Obviously I want to show graphically the LHD. What will be LHD? LHD is equal to 0 at this point and RHD also 0 at this point, and value of the function at the point x is equal to 2 is 0. For this, the function is continuous because LHL is equal to RHL is equal to f of 2 is equal to 0. The function